Hi there, geometers. I am here to talk you through the angle addition postulate, what it is, what it means, how we use it, and give you some examples. So first of all, the angle addition postulate assumes you have an angle. Let's go ahead and name my angle ABC. Okay, and it's like, if you haven't seen my video on segment addition postulate, you might want to look at that because I'm going to make some comparisons here. The segment addition postulate and angle addition postulate say very similar things. One's about segments, one's about angles. And like the segment addition postulate, it sort of goes with the idea of between in terms of the setup. Here's what I mean. You have an angle, and then you have a point that is in the interior of the angle. Okay, like let's call this point F. Okay, and what that does is that sets up a situation where you could draw a ray that goes from the vertex of your angle through point F, and that ray is between the two rays that make up the original angle. So you pretty much just have one bigger angle split into two smaller pieces by this ray that goes through it. Now, we are not implying that that ray goes right through the middle. I'm not saying that's the angle bisector. It just goes through somewhere. It may not be right in the middle of this angle, and therefore we're not going to make any assumptions that it is. Okay, and so what we have is we have this situation where the smaller two angles then, ABF and FBC. Remember to name an angle with three letters. We start with one side, go to the vertex, and then go out the other side. Always have to have the vertex second. So I could have named this angle ABF, or I could have named it FBA, but B has to be in the middle. So ABF and FBC together make up the entire angle. Okay, so now what I just wrote is actually incorrect. It's not incorrect in terms of what we're saying. It's incorrect notation-wise. Because what we're really going to talk about here is it's the measure of the smaller two angles. The measure of this angle, however many degrees this angle is, and the measure of this angle, however many degrees between here, have to add up to the number of degrees or the measure of the big angle. So we're going to use little m's to be accurate. So the measure of one smaller angle plus the measure of the other smaller angle equals the measure of the whole bigger angle. And another way we can think of that, just like segment addition postulate, is that one part plus the other part equals the whole thing. The whole angle is the sum of its parts. Okay, so that can be useful if we're trying to find things like missing angle measures or trying to solve equations. So in our first example, I drew this little angle, well, multiple angles. We have three angles here. We've got the whole big one, and then we've got each of the two smaller ones. So let's suppose that I am given this information about these angles. Okay, so I am told that the measure of angle TMS, which you could think of, let's go ahead and do this. You could think of it as this angle right here, that's TMS, is 12 degrees, and LMT, which I'm going to think about like this whole angle all the way across, that's LMT. So LMT is the whole big one, is 39 degrees. And I'm supposed to find LMS, which is this part right here. That's the leftover part. Okay, so let me just make a squiggle. These are not congruence markings, okay? This is just me trying to show where that angle is. Okay, so again, we've got part plus part equals whole. And in this particular case, the two smaller parts are the two smaller angles are, and let's go from this side, LMS, so the measure of angle LMS, plus next smaller one, the one that's sort of pinkish here, SMT, the measure of angle SMT, is equal to the whole thing, which is LMT. LMT. Okay, so that is how I can set up my equation, and I'm just going to substitute in this information that I was given. TMS is the same as SMT. Okay, you could turn the angle name around as long as you keep the vertex in the middle. So this is 12. LMT is 39. and the one we don't know, let's just call x. We don't know the measure of angle LMS. That's what we're being asked for in our problem. So here's my equation. The angle addition postulate just pretty much told me how to set up the equation so that I can find that missing angle. And I'm going to subtract. Now that I have an equation, I just have to pull out my equation solving skills and I will be able to get the answer. So x is 27. So in other words, going back, we've got this was 12 degrees and this is 27 degrees. And then we can sort of check ourselves here. Not really sort of, we can check ourselves here. 27 plus 12 has to add up to the entire angle, and that's 39, and that is correct. So my answer for x was 27, and in this case, x stood for LMS, so that was what I was trying to find. Anytime you solve an equation, you have to check and say, is the variable what I was trying to find, or do I have to maybe go back and plug it in? But here the variable stood for the entire angle, and it was the one that we were trying to find, so there's nothing left to plug in. Okay, let's look at another example like that, one that's perhaps a little bit more algebraic. Let's suppose I have this figure, and I am told that I have this info. Okay, I know that the measure of angle MNP, I don't like that's too far over. There we go. MNP is 3x. PNR is 2x minus 6. And MNR, that's the whole big one, is 44. And I can see that these two smaller angles here add up to the whole, or make up the whole big angle. So it will be an angle addition postulate situation, where the two smaller parts make up the entire angle. Okay, now I did not write this completely accurately on purpose because I wanted to show it to you guys. Sometimes this confuses people. Notice that I didn't put degree symbols up here. Because it's not just a number, if I wanted to add the degree symbol, which is something I need because we measure angles in degrees, so it will be in degrees, I really need parentheses. Now, a lot of teachers aren't going to be mad at you if you don't put parentheses and you put a degree symbol there. But I just want you to understand why sometimes they do that, is they're saying this whole thing is a number and it's that many degrees. In other words, there's nothing special about those parentheses. They're just there because it's kind of technically inaccurate to put the degree symbol beside something that's not a number. Okay, so now we're ready to start setting up our equation, and we use the angle addition postulate to set up our equation. So we have part plus part equals whole. In this case, one part is MNP. And just like I said in the segment addition postulate, you don't necessarily have to write everything I'm writing now. The next part is PNR. And this is really just like if your teacher asks you to write an equation to show how it's set up, then yeah, write it. If you like to write it because it helps you solve the problem, write it. Otherwise, you don't have to. The whole thing is the measure of MNR. And now I'm going to substitute this information I was given. MNP is 3x plus PNR is 2x minus 6 equals MNR is 44. So now I have an equation I can solve, and I've got 3x's and 2x's is 5x's. And I solve my equation just like any other equation. And I get x is 10. Now, perfect example of here I got the value of my variable, but I'm not sure if that's what's being asked for. I didn't actually tell you what's being asked for. So this is where, however, I would go ahead and say, is that what I was needing? Was I asked to find x or find the value of the variable? Or was I maybe asked something like, find the measure of angle MNP? If I was asked to find the measure of angle MNP, I need to take this 10 and go put it in to MNP, and I get 3 times x becomes 3 times 10, which is 30 degrees. It could have asked me for angle PNR. 10 plugged in here would give me 2 times 10 is 20, minus 6, 20 minus 6 is 14 degrees. And here again we get to sort of check ourselves because 30 plus 14 it does add up to 44. So it all makes sense and we must have done it right. Hope this helped, and I'll see you again next time.